Hello GATE aspirants, I am Dr. THILAGAVATHI, Associate Professor, CSE Department, S.A. Engineering College. Today we will see some of the GATE 2023 questions in computer networks. The first question is, suppose two hosts are connected by a point-to-point link and they are configured to use stop and wait protocol for reliable data transfer. We have to identify in which one of the following scenarios the utilization of the link is lowest. So, four options are given: longer link length and the lower transmission rate, longer link length and the higher transmission rate. And the other two options are shorter link length and the lower transmission rate. Shorter link length and the higher transmission rate. Let us see how to solve this question. So first let us know what is stop and wait protocol. Stop and wait protocol is the simplest flow control protocol where the sender sends a data packet to the receiver and then waits for the acknowledgement. On receiving the acknowledgement, the sender sends the next data packet. This is how the stop and wait protocol works. So in the question we have to compute link utilization of the point-to-point link. So to calculate the link utilization, the formula is Tx by Tx plus 2Tp. So Tx is the transmission time and Tp is the preposition delay. So how to find the Tx? Transmission time is length of data divided by bandwidth. To calculate preposition delay, we have to divide distance by speed. So from this, using this you have to find the link utilization. So link utilization formula is Tx by Tx plus 2Tp. So this can be written as 1 by 1 plus 2Tp by Tx. So by supplying what is the Tp and Tx, we will get the formula in this way. So in order to get the lower utilization, here the link utilization is inversely proportional to distance and it is also inversely proportional to the bandwidth. So we have to calculate the link in order to reduce the link utilization. We have to increase the distance and also to increase the bandwidth. So our answer here is the this one, that is the answer is B, longer link length and the higher transmission rate is the answer for this question. Next we will see the another question. A keyboard connected to the computer is used at a rate of 1 keystroke per second. The computer system polls the keyboard every 10 milliseconds to check for a keystroke and consumes 100 microseconds for each poll. If it is determined after polling that a key has been pressed and the system consumes an additional 200 microseconds to process a keystroke. Let T1 denote the fraction of seconds spent in polling and processing a keystroke. In an alternative implementation, the system uses interrupts instead of polling. An interrupt is raised for every keystroke. It takes a total of 1 millisecond for servicing an interrupt and processing a keystroke. Let T2 denote the fraction of the seconds spent in servicing an interrupt the processing a keystroke. So we have to find out what is the ratio of T1 and T2 that we have to calculate. So in order to find the polling time T1, the polling time is calculated from the given time, that is 10 milliseconds. So in the given poll 1, for every poll 1, in 1 second 1000 milliseconds time is used. So in 1000 milliseconds we can send 100 polls. Okay, so to calculate the time spent in polling, we have to send, that is 100. We have to send the 100 microseconds for each poll. So that we are multiplying 100 into 100 poles, which is equal to 10 milliseconds. So time spent in polling is 10 milliseconds. For each keystroke, 200 additional microseconds are used for each keystroke. So which is equal to 0.2 millisecond. So the transmission polling time T1 equal to 10 millisecond plus 0.2 millisecond for the keystroke, which is added together to get T1. Then T2 is 1 millisecond, that is for servicing the interrupt and processing the keystroke. So T1 by T2 will give you the ratio between the T1 and T2. So this 10.2 millisecond is the answer for the given question. Now let us see the another question in the GATE 2023. Suppose you are asked to design a new reliable byte stream transport protocol called TCP. This protocol named MyTCP runs over 100 Mbps network with a round trip time of 150 milliseconds and maximum segment life of 2 minutes. Which of the following is or valid length of sequence number field in MyTCP header? So here 4 options are given. Here you can choose one or more options as an answer. So in order to find the sequence number field in the TCP header, we have to check that we can transmit 100 Mbps, that is MB of data in 1 second. So this can be converted into this form, that is 100 into 10 power 6 bits, and then convert this bits into byte form, that is 100 into 10 power 6 divided by 8 gives you the bytes of data that can be sent. So here our question is to find the maximum segment lifetime for 2 minutes. So now we are calculating the bytes sent in 2 minutes, that is multiplied by 120 into 10 power 5 bytes in 1 second. So this can be calculated in this way, that is 15 into 10 power 8 bytes in 120 seconds. So in order to find the sequence number field in MyTCP header, you have to convert this in the with a log 2 base 15 into 10 power 8, which will give you the sequence number. So after computing this, you will get the sequence number is greater than or equal to 31 bits. So your answer is in this given answer, all the answers are, these 3 answers are greater than 31. So your answer is B, C and D. So next let us see the another question in GATE 2023. Suppose in a web browser you click on a www.gate2023.in URL, the browser cache is empty. So the IP address for this URL is not cached in your local host. So a DNS lookup is triggered by the local DNS server deployed on your local host. Over the 3-tier DNS hierarchy in an iterative mode, no resource record or cached anywhere across all DNS servers. Let RTT denote the round trip time between your local host and DNS server in the DNS hierarchy. The round trip time between the local host and the web server hosting www.gate2023.in is also equal to RTT. The HTML file associated with the URL is small enough to have a negligible transmission time and negligible rendering time by your web browser, which references 10 equally small objects on the same web server. Which of the following statements is or correct about the minimum elapsed time between clicking on the URL and your browser fully rendering it. The four options of the answers are given. So first option is 7 RTTs in case of non-persistent HTTP with 5 parallel TCP connections. Second option is 5 RTTs in case of persistent HTTP with pipelining. And third option is 9 RTTs in case of non-persistent HTTP with 5 parallel TCP connections. And the fourth option is 6 RTTs in the case of persistent HTTP with pipelining. Let us solve the question with the persistent. Let us know what is persistent HTTP. Persistent HTTP is the clients send HTTP request and the server has to acknowledge the request. So in that case, sending request, after receiving the acknowledgement only the packets are transferred. That is a kind of persistent HTTP. Then what is pipelining? Pipelining in the sense when the server sends a request, it waits for the acknowledgement in the pipeline. That is called pipelining. So here we have to calculate the number of round trip time required for the given URL and your browser for fully getting the 10 objects. Okay, so to calculate that we have to go for persistent HTTP type. Okay, so host connect with the DNS server to resolve the domain name and get the IP address. For this process we have to get 3 round trip times. One is for getting host connect with the DNS server, and the second RTT for resolving domain name, and the third RTT is to get the IP address. And then next one is the client establishes TCP connect with the gate 2023.in server which require 1 RTT. And then for the third way, the client send request to the HTTP file. For requesting HTTP file, it takes 1 RTT. And then next the client sends request to the server and get 10 small objects in 1 RTT. That is totally we are getting 3 plus another 3 RTTs. So totally we get 6 RTTs in case of persistent HTTP pipelining. So here we are getting the persistent HTTP pipelining in order to get the result. Otherwise, if this is not the matching answer, we have to go for non-persistent HTTP type of transmission. So with this we complete our lecture. Thank you. All the best.